So the topics to be covered in this lesson are introduction, measurement of time, rest and motion, uniform and non-uniform motion, speed, scalar and vector quantity, velocity, distance time graph. So first I just want to give some introduction that already we learned that the different modern day watches, stop clock watch and the digital watch, then pendulum clock, these are all used. Then historically the first early clocks were used, and then we learned about the simple pendulum. We learned some of the important definitions in it. So I would request you to go back, check the videos of part 1 and go through it. Just link the topics and then come back, because it will help you to link the concepts and it will help you for better conceptual understanding. So now coming to the rest and motion. Now a body is said to be at rest if it does not change its position with respect to its surrounding. If a body changes its position with respect to its surrounding, then the body is said to be in motion. Suppose a book is lying on the table and the book is at rest with respect to the surrounding, but the earth is revolving around the sun, and therefore anything lying on the surface of the earth is also in motion. We can conclude that the book is in motion with respect to the sun. Now let's suppose if a person is traveling in a train and he passes by another person standing alongside the track. The person standing along the track will see the person and everyone else in the train as being in motion. But all the persons sitting in the train will be stationary with respect to each other, right? You must have experienced it some time. So an object may be in motion with respect to another object, but may be stationary with respect to the third object. So this is what is about the rest and motion. Now coming to the uniform and non-uniform motion. If a body covers equal distances in any equal intervals of time, however small the interval may be, then the motion is said to be uniform. The example such as if a car travels 80 km every hour and 40 km every half an hour, 20 km every quarter of an hour, and so on, the motion of the car is said to be uniform. And if a body covers unequal distances in equal intervals of time, then its motion is termed as non-uniform motion. Coming to the speed, an object is said to be moving when it is changing its position continuously with respect to its surrounding objects. We observe many moving objects around us. Now the question arises is the comparison of motion of different objects. How to decide which one is moving slower and which one is moving faster? Now suppose if we observe the motion of a car and a bicycle on a road, and it is noticed that during the same time interval, the car is able to go much farther than the bicycle, and it is said that the car moves faster than the bicycle. The distances covered by different objects in given time can be used to compare their motions. And we see that a distance traveled by an object per unit time is called its speed. So the distance covered in 1 second gives an idea how fast the car is moving as compared to that of the bicycle. If an object covers a distance d in time t, then it is said that speed is equal to the distance covered upon time taken. Now the standard unit of distance is meter and that of time is second. The SI unit of speed is meter per second. Some speeds may be expressed in units like kilometer per hour, meter per minute, or meter per hour. And generally, measure distance moved by a body over a time period of many seconds. It is usually not possible for a body to keep on moving at a uniform constant rate over a large interval of time. So the average speed total distance is calculated as total distance upon total time taken. Now there is a concept called as uniform speed. It is a body said to be moving with uniform speed if it covers equal distances in equal intervals of time, right? Now suppose a car runs at a speed of 36 km per hour. The speed of the car will be uniform only if it covers 18 km every half an hour, 9 km every 15 minutes, 3 km every 5 minutes, 300 meter every 30 seconds, 1 meter every tenth of a second, and 1 centimeter every thousandth of a second, and so on. The car has a uniform speed only if it covers equal distances in smallest possible equal intervals of time. Now coming to the variable speed, a body is said to be moving if variable speed if it covers unequal distances in equal intervals of time or equal distances in unequal intervals of time. However, the small time intervals there may be. Now, you must have seen a meter fitted on the top of a scooter or on the dashboard of a car. Now the diagram background of you can see. So one of the meters has kilometer per hour written at one corner, and this is known as speedometer. The speedometer records the speed directly. There is another meter which is called as odometer, which measures the distance moved by the vehicle directly. So this is all about the uniform and variable speed. Now coming to the scalar and vector quantity. What exactly scalar quantities is? Scalar quantities are those quantities which contain magnitude only. Example, mass, length, speed. And vector quantity are those quantities which possess magnitude and direction both. Example, weight, force, momentum, and velocity. Now we learn velocity in more detail. Velocity. In order to have a complete information about the movement of body, we must know not only it's the speed of the body but also the direction of motion. The physical property which gives both speed and direction of body is called as velocity. And if a car is moving from west to east, with a speed of 60 km per hour, and we say that the velocity of a car is 60 km per hour east. Now, this is all about velocity. Here, what you have to remember important is the definition of velocity. Coming to the distance time graph, we generally come across various forms of graphs in newspapers and magazines, and they provide greater details of information and make information more interesting, right? Now you can see the first graph, which is called as the bar graph, which is showing the birthday of students by month. So it is showing the number of students and by months, like which month is having, how many numbers are there having birthdays. So the other diagram, which is showing the pie chart, it is a graphical representation and it gives information in the form of comparisons. Now there are some comparisons you can see over there. And the third graph is the line graph. So it's showing the lining representation, right? So these are all the three types of distance time graph, which is pie chart, then line graph, and bar graph. So this is all about the motion and time. I hope you're enjoying the video. Stay tuned for more lessons to come. Enjoy the videos and subscribe for more video updates. And thank you for watching.